Good morning, and myself R. Joseph Paul, Assistant Professor, Department of Mathematics, SNS College of Engineering, Coimbatore. So, in the previous class, we were discussing about how to find the eigenvalues and eigenvector. So, we discussed about its formulas and its definitions. Now, we are going to determine how to solve an eigenvalues and eigenvector. So now we look into a problem. Find the eigenvalues and eigenvector of a matrix A. It is taken as minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. So here a 3 by 3 matrix is defined. Now we have to define an eigenvalues and eigenvector of the matrix. So we know the procedure how to find eigenvalues and eigenvector. First we have to define a characteristic equation of the given matrix. Then we have to find the eigenvalues. Then we have to find the eigenvector for the corresponding eigenvalue. This is the procedure. So here the given matrix is a 3 by 3 matrix. So the characteristic equation of the 3 by 3 matrix is defined as lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Where s1, s2, s3 is calculated. S1 we know it's a sum of the main diagonal element. So the sum of main diagonal element we are saying it as minus 2, 1 and 0. When we add we are saying it as minus 1. S2 we are saying it as a sum of the minor matrix of the main diagonal element. So we need to find the minor matrix of the corresponding diagonal element. So the minus 2 it's a first diagonal element. So its minor matrix is going to be 1, minus 6, minus 2 and 0. And second diagonal element is 1 and its minor matrix. So the second row and second column will be eliminated. So the remaining elements is taken minus 2, minus 3, minus 1 and 0. So the third eigenvalue we are saying it as 0. So third row and third column will be eliminated. So its minor matrix is going to be minus 2, 2, 1 and 2. By solving the determinant value we will have its sum of the minor matrix as S2. We are saying it as minus 21. S3 we know it is determinant of A. So we are finding the determinant of the matrix. So the determinant value of this matrix we are saying it as 45. So now we need to solve the characteristic equation. So we are saying by substituting the value of S1, S2, S3 we'll have a characteristic equation. So we need to solve the characteristic equation to find the eigenvalue. So when we solve the characteristic equation by synthetic method, so we are saying the roots of that eigenvalues are minus 3 and minus 3, 5. So here we are saying two eigenvalues are repeated, one is different eigenvalue. So minus 3 it's repeated twice and 5 is the different eigenvalue. So the roots of the characteristic equations are minus 3 comma minus 3 comma minus 5 we are saying. So next we are coming across to find the eigenvector. So to find the eigenvector we are saying its formula is A minus lambda I of x is equal to 0. So A it's a given matrix, minus lambda of I is an identity matrix, so lambda will be multiplied. So we have a diagonal element as lambda of x1, x2, x3. x1, x2, x3 are called as the eigenvectors. So we have to find the unknown values of x1, x2 and x3 for the corresponding eigenvalues minus 3 and 5. So when we have a substituting a lambda a minus lambda I of x, we'll have minus 2 minus 1 2 minus 3 as a first row, 2 1 minus lambda as 6, y minus 1 minus 2 0 minus lambda by solving a minus lambda I of x1 x2 x3. So case 1 we are substituting a lambda value as minus 3. So when the lambda value is replaced as minus 3, we'll have a matrix in the form of 3 by 3. Now we are multiplying the matrix. So we'll have a 3 equations with 3 unknowns. Now we need to check whether all the 3 equations are same or different. If all the 3 equations are different, we can choose any 2 equations to find the vector. If all the 3 equations are 0, its only meaning is all the three equations are same, its meaning is all the equations are repeated, so we have only one equations. And third case, we are saying that any two of the equations are same, one is different. So when any two equation is different, that is same, one is different, we have to choose one equation from the same and we have to take a different equation to find the vector. So these are the properties we are saying. I need to check all the three equations, so this condition will be followed in it. So here we are saying that all the three equations are same, so we are taking it as x1 plus 2x2 minus 3x3 is equal to 0. When all the three equations are same, it is not possible to find the value of x1, x2, x3. So we are finding the value of x1, x2 and x3 by choosing any one of the values are 0 when the equation is, all the three equations are same. So let me take x1 as 0. So we'll arrive 2x2 minus 3x3 is equal to 0. So we are saying 2x2 is equal to 3x3. So by interchanging its coefficient, intercepting variable, 2x2 by 3 is equal to x3 by 2. So the first vector, it is arrived in the form of x1 is equal to x1, x2, x3. So we are saying it as 0, 3, 2. Now we are coming across with case 2 when lambda is minus 3. Similarly, we have a same equations because when we are taking lambda is equal to minus 3 in the first case, we are arrived with the same three equations are same. So similarly, when we are coming across with the say case 2, we are saying lambda is equal to minus 3, the roots are same. So I cannot choose x1 is equal to 0 here. So I am choosing another variable, that is either x2 or x3 as 0. In this case, we are choosing x2 as 0. So we will have another vector in the form of x2. We are saying x1, x2, x3 as we are saying it as 3, 0, 1. Similarly, we are coming for case 3 when lambda is equal to 5. We will have an equations. So here we are saying all the three equations are different. So we can choose any two out of this. So by taking two equations, we are using ratios method, that is intercept method, to find the variable x1, x2, x3. So here the third vector, it is arrived in the form of minus 1, minus 2, 1 by solving the two equations by using intercept form. So this is how we are finding the value of x1, x2, x3, finding the roots of the equation, that is we are forming the characteristic equation and we are finding the roots and we are finding the eigenvector for the corresponding eigenvalues. Thank you. We'll see in the next class.